Okay, we're recording. Welcome to this webinar. My name's Liam Walton. Most of you will know me, Managing Director here at Matrix Technology Solutions. I've got with me John Dobson. John is the owner and chairman of the company. He's going to deliver the majority of the presentation for you. And then I also have Alistair Johnson in the room with us as well, and you'll be able to see him on camera too. Okay. Today, we want to present to you our new range of automotive training equipment based around our electronics. This is a new range that we've been working on for a long time. It's very exciting for us to be able to bring this to market now. And as you'll see throughout John's presentation and the demonstration that we deliver towards the end, there's a lot of new stuff here for us to be excited about and to show off to customers. So we're happy as we go through to take any questions that you might have. You can either pop your questions into the chat and I'll make sure we address them at the end, or you can unmute yourself. I have muted everyone's mic for the moment, just to avoid any noise or anything on the line to make sure everything's clear. But we do really welcome any feedback whatsoever that you might have. What we'll do afterwards is once the recording is downloaded and ready, we'll ensure that we send you that along with the slides from the presentation, pricing and any other information that you might need. Although I know that we sent an email out about this a week or so ago, so you probably have most of that already. Okay, so I'm just going to share screens with you and hand over to John. You should be able to see that now. Please, like I say, give us a shout if you have any questions whatsoever. Thank you.
Okay, good afternoon. Let me just start by introducing the whole range to you. Basically, we're discussing 6 products here, and they're split into different academic levels. Here in the UK, we talk about levels 1 to 5. Level 2, to give you an idea, is something equivalent to an examination that a typical student would sit at 16 years old, and level 3 is equivalent to an examination a student would sit at 18 years old. And what we have is we have a couple of basic kits, automotive electricity and automotive fault finding, and then we have 4 slightly more advanced kits, and they are motors, generators and charging systems, automotive ECU architecture and logic, oscilloscope use, and high voltage and battery circuits. And so those are the 6 products we're launching today. We have a couple of other products in automotive, sensor control and CAN bus, and they remain unchanged. So there's no changes for those 2. It's basically the sort of bottom end that we have revamped. In order to do this, we had to create quite a number of new components. And of course, a major theme now in automotive is electric vehicles. And so we've done a lot of work with those in mind. And the first new component we've created is this motor generator pair. And it consists of a DC motor, 24 volts, 50 watts, and a brushless DC motor. And they're mechanically coupled together. And the coupling is under this clear perspex tube, so that there is no risk that students' hair or ties or anything can get caught up in the mechanism, because these motors generate some power. And we needed to have a reasonable power motor to demonstrate how a number of principles work. And this setup is really great because you actually get 4 machines in one. So you get a DC motor, and the brushless DC motor, when it's turned by the DC motor, actually generates 3-phase. So you've got a 3-phase generator there. And that's great for showing how cars generate 3-phase, and also how you can rectify that 3-phase to make DC. Now, conversely, you can also drive the brushless DC motor, and you can generate DC on the DC motor. It acts as a DC generator. Now, brushless motors are slightly more complex to drive. It's a 3-wire signal, and this box here contains some driver circuitry. So you basically give this box 24 volts and a small analog signal, which dictates the speed between 0 and full power. And the 3 outputs, U, V, and W, just connect to these 3 inputs here to the motor. So there's a driving system. And this is a really neat way of teaching all sorts of things in terms of motors. So that's our first new component. Now just another little bit about the brushless. You can see there that both components are actually 50 watts. They're both the same power, but the brushless DC motor is much smaller. And so the power to weight ratio is vastly better than the DC motor. It's also in some ways cheaper. It uses much less copper. It uses a little bit more silicon in terms of the driving circuitry, but silicon's really cheap. And the brushless DC motor is the most important motor used in vehicles today, not just in the actual drivetrain, but they're also used in lots of other parts of the vehicle, windscreen wiper motors and things like that. Obviously, the power to weight ratio and ultimately the more eco-friendly and cheaper benefits that it brings. Okay, another couple of components we've got is in electric vehicles, there are now multiple voltages. The battery might be typically, say, 300 volts, whereas many of the circuits are 12 volts. The voltage generated on regenerative braking and other things can be perhaps 100 volts. And so a big part of vehicle electronics these days is converting one voltage into another. And this is done through circuitry that we refer to as an up converter or a down converter, depending obviously whether it's increasing the voltage or decreasing the voltage. And so what we've done is we've made 2 small up converter, down converters, and they sit on the standard electronics carriers, and they've just got small potentiometers on them, which dictate the amount of amplification, if you like. So these are used extensively in our curriculum to show how this part of the circuit in modern vehicles works. Another thing we've done, we've got a pack called fault finding, and very often when we're teaching electricity electronics, it's actually understanding the wording and what the wording means. And so we've just taken a very simple step. We've just put some words on some carriers and put some resistors under those carriers. So the students can, for example, insert a bad earth into a battery circuit and they can see what the effects on that circuit are. And that's an incredibly simple move, but I think actually it'll be a very popular one. We've had an automotive sensor control product based on our MIAC ECU for a while, and we had a lot of comments from customers that that was too expensive, and they were quite right. I think the MIAC itself in a case is about £600. And so what we've done is we've cost reduced that, and we've now come up with a micro ECU, which is basically a small computer. It's got a little display on it and some program selection switches, and it's just got 4 input outputs, A, B, C, and D, and their behavior is dictated by the program. They can be analog or digital outputs. They can be pulse width motor outputs or just normal digital outputs. It's programmed with about 20 programs, and it can be reprogrammed if you want to. And our motivation there is that we'll make a much cheaper way of offering ECU and digital courses, and we'll go over some details of that shortly. I'm really very keen on these components. These are basically just batteries, and there is a 6-volt sealed lead acid battery at 1.2 amp hours and a 3.7 volt lithium ion battery at 2.6 amp hours. And you can see the lithium ion and the lead acid battery there, and they are fully fledged batteries, so they're not toys. The lithium ion battery in particular is exactly the same one as is used in Tesla vehicles. We happen to have 6 in our batteries kit. I think a Tesla has something like 1,000, but the principles are exactly the same. The way they're charged, the way they're managed are the same. The voltage characteristics are the same. And so we've included these in some kits. Now, when you're doing experiments with batteries, you have to be a little bit careful. If you mistreat them, they can occasionally explode. And so we've encased them in stainless steel. They also have internal fuses. That alters the characteristics very, very modestly, but it means that there's a decreased chance of students either harming the battery or of doing something else that they probably shouldn't be doing. Having said that, they do generate wonderful sparks if you short circuit them, and I'm sure the students will find that out for themselves. We've also introduced some circuit breakers. In the fault finding course, we wanted to show the position of fuses. That's not advisable in one sense because the students would keep breaking the fuses if we included real automotive ones, whereas this little circuit breaker, when it gives out more than 2 amps, the little button just pops up and the students can reset it if they need to. But it allows us to show the position of the fuses in the circuits. Our goals here, let's just reiterate what we're trying to do. There's always a little bit of controversy because in some countries, the teachers are still insisting that students will learn electricity on a vehicle. And of course, that presents some challenges because it's difficult to get 30 students to work on one vehicle at the same time. And so our goal rate basically is to prepare students for the point at which they are going to have to go onto a vehicle to either repair it or to understand how it works. So our philosophy is that we do all of the preparation work in the lab, and then the students can get their hands dirty on the real thing. And we do this by the provision of, hopefully, great resources and great workbooks. Let's look in a little bit more detail then at each of these kits. The automotive electricity is really just a relatively minor update of the current basic electricity pack that we've got. What we've done is we've just added quite a few relays, solenoids, and a few other parts just to bring it up to date with some of the syllabuses here in the UK. But it's really not too different from our existing LK71. Now, this is a snapshot of one of the pages from the manual, one of the worksheets. The worksheets are all in color. They're all free of charge on our website. The teachers can download them, print them, and do what they like with them. They all have teachers' notes in. They have student handouts as well. So the idea is that the student writes onto the handout, not on the main workbook. They can be laminated by teachers or they can be used how they wish. In each worksheet, we tend to have a little bit of context and a little bit of a photograph. So here, this is about a relay, and we're showing the students what an automotive relay looks like. They're all very clear in terms of the wording and the diagrams and how they're used. You can see that a bit more here. I've just included a little snapshot of 4 or 5 of the worksheets that are available in that particular pack. The fault finding is new for us, and actually we anticipate that whereas in the past you might have just sold the basic automotive electricity kit, we think that you will now always sell the fault finding kit and the basic kit. Fault finding is the essence of what this subject is about. And the learning objectives here, you can see them there, are first of all multimeters and clamp meters. There's a lot of energy has gone into this basic kit to explain how students use multimeters to test components, and there is a single worksheet on nearly every single type of component that they would find in a car, and we cover how to test it with a multimeter in circuit and out of circuit. We're using clamp meters a lot. These are lovely little instruments. They're very cheap now. They're great for measuring current without having to interrupt the circuit like you do with a multimeter. And they're used extensively in industry. And we feel that colleges should be using those as well. So there's a lot of work on multimeters and testing components, a lot of work on circuits, including open, shorts, bad earth and corrosion. And we also include fundamental instruction on how to use things like voltage tables to do fault finding in vehicle circuits. Here's a picture of one of the clamp meters in use. This particular Voltcraft meter, I've shown a kind of a plan view there and a side view. The little jaws open when you press that switch and you clamp it around the link, and it gives you a very accurate reading of current. We also like using fluke meters. The fluke meters really are very good, probably 6 or 7 times the price of a conventional multimeter, but for some reason they just work so well and they're so nice to use, and they're certainly worth it. And I know that they're very popular in automotive workshops. This is an example of one of the fault finding circuits in the fault finding pack. So this is just a lighting circuit, probably from quite an old fashioned car. There's no ECUs involved, and it just shows the setup between headlight switches for main beam and normal, and it shows how relays and bulbs and switches are used to achieve that circuit. And what we do here is we paint a little scenario for the student. So in this case, a customer complains that neither his high or low beam lights come on the left side of the car, and the student deduces that there are 4 possible different reasons for this fault, and then they have to build a voltage table to understand which one of those is the most likely cause. And we think that automotive teachers will love that kind of style of presentation. There you can see, again, just a snapshot of all the different worksheets that are available. So you can see the energy and effort we've put into providing quality curriculum. Motors, generators and charging systems. We had a package on this. We've just beefed it up quite considerably with the use of the HP 2001 motor generator pair. We're now covering motor principles, electric motors, 3-phase and DC, 3-phase and conventional rectification, charging systems, voltage regulation, and we've got a new section on generating high tension in vehicles. And this has worked out really, really well. We often sort of sit and speculate how we might teach certain things, and with varying degrees of success, but this one is really, really good. I'm really pleased with it. The use of oscilloscopes is a recurring theme now in a lot of what we're doing. And this is a great exercise in oscilloscope use, where students have to measure the width of the spark discharge in a petrol driven car. And that width is proportional to the quality or energy in the spark. And what we do, we've constructed a circuit that's very similar to the high tension circuit in a vehicle. So we've got a power supply, a switch, a transistor, which is putting current through this inductor. And current flows when the switch is closed. And when the switch is opened, the circuit rings and produces a high voltage at this point. When the voltage at this point exceeds 16.7 volts, these 2 Zener diodes break down, and the energy that's in the coil can dissipate through this path here, through those diodes. And that's exactly what happens when a voltage in a spark plug circuit goes beyond a certain point. A spark discharges effectively the energy in the coil. And what we do is we can put a resistor either in the low tension or the high tension side of the circuit, and they have a similar effect, which is to reduce the energy stored in the inductor, and therefore to reduce the time, the period of the spark. And it's worked remarkably well. We've got a little micro ECU there at one point, so we get a repetitive spark as well. So students can just understand if there is a resistance in a high tension lead, or there's a resistance in the low tension wire, or the coil is getting high resistance for whatever reason. They can understand how that circuit is affected, and they can practice using an oscilloscope to measure the pulse width to debug the circuit. So that's worked really well. Again, here's a little snapshot of the style and types of worksheet that are involved. And you can see we're using the motor generator pair quite extensively in this kit. That's worked out really well. So ECU architecture and logic. This was a real pain to construct because we wrote the whole thing, and then we showed it to, it was Hyundai Canada, not Kia Canada. We showed it to Hyundai in Canada, who showed us how they teach this subject, and they were teaching it in a way that made us rethink how we were going to teach this as well. So we rewrote the whole thing, having talked to them, which was kind of a pain, but kind of really good, because I think we've ended up with a much better product than we would have had otherwise. So in this pack, we're still teaching a little bit about logic. Here in the UK, I think the teachers are still keen on teaching how individual logic gates or how the function of and NAND and so on work. So we teach a bit of that. We teach about analog inputs, about sensors, about pulse width modulation, digital outputs, transistors and relays. Fiber optics have gone in there. We've got some lovely little fiber optic components, and then control in open and closed loop. And of course, faults are in here as well, quite a lot of fault finding. And the way we've taught that is we've done it all in an ECU context. So what we do is we get the students to build this ECU that you can see here, and then they use that in lots of circuits. Now this ECU is basically a small computer, and you can choose the program with these two switches, and it has two inputs. Now the inputs have a couple of resistors to act as potential dividers. The actual chips used in ECUs are either 3.3 volts or 5 volts, but of course the outside world is 12 volts. So these two resistors just step that down and produce about 5 volts there. There's one output which is a transistor. So basically you tie a motor or bulb between plus volts and that point, and then the ECU can switch that. And here then there's a transistor and a relay. So you can attach things to output 2A and B, and you can use that as just a straightforward switch. It's got a 12 volt and ground, and that's essentially 95% of what ECUs do. They have a communications port as well, of course, in CAN bus, and there are inputs and there are different types of outputs. And what we do is we take that a stage further. We use 3 electronics-based boards that clamp together, and we get students to construct the input and the output. And because they use this same circuit throughout most of the experiments, it doesn't actually take long to construct the different types of experiment. In this case, we've got some kind of logic system. We've got two input switches. You can see all the circuit breakers in use, and we've just got 2 output lights there that we're using to discover how and NAND circuits work. And we think that's a really neat way of teaching students ECU behavior and also what's inside ECUs. So you can see again a little snapshot of quite a few of the different worksheets when we're discussing the NOT gate, pulse width modulation, fiber optics, a couple of fiber optics there, and then a fault finding project. Okay, the next kit up is high voltage and batteries. Here we're discussing different types of battery, lithium ion and lead acid, and we discuss testing batteries. It's relatively straightforward for lead acid. It's very difficult for lithium ion. We talk about the discharge characteristics. So that is the voltage out with the change of state of charge of the battery. And we talk about how to charge them as well. And of course, they have to go through a charging process because the batteries will discharge as they're used. We talk about how to build bigger batteries from smaller batteries, how to build them in series and in parallel to get the overall battery characteristics that you want. We talk about DC to DC converters, up converters and down converters, speed control. We talk about 3-phase again. We talk about service disconnect with relays, and you'll see that in a moment, residual charge on capacitors. And we talk about the need for multiple voltages in a vehicle. And then we talk about the role of transistors and diodes in vehicles. Now, the largest voltage we use here is around 30 volts, so it's still perfectly safe. There's no risk of any electrocution of students. Here you can see another typical circuit. Basically, you've got 7.5 volts going in, you've got 12 volts out, and students are just investigating a simple up converter, measuring the voltage and current in and the voltage and current out, and coming to some kind of conclusion about the efficiency of this kind of circuit, because it's never 100%. This is the one of the last experiments, if you like, in this pack, and I really like this because it shows students lots of different processes that occur in vehicles. This is a fictional circuit. You'll never actually find this in a vehicle, but it demonstrates a lot of the different technologies used in the vehicle. So on the left-hand side here, we've got 6 lithium-ion batteries, which are creating around 24 volts. both the positive and negative side of these batteries are controlled by relays. So when you're servicing a vehicle, you disconnect both the positive and negative. And those relays are both controlled by a switch on a 12-volt battery here. Sorry, this is a 6-volt battery. Two of them together make 12 volts. So when that switch is energized, those relays turn on. If that switch is on, then 24 volts is provided to the DC motor. That turns the brushless motor. That creates three-phase, which is then rectified by these bridge rectifiers. And I've got a little bit of corrosion in there as well. There's a little bulb there to show that electricity is being generated, and it is smoothed by this large capacitor. That produces around 8 volts there. And then that 8 volts is being converted by an up converter up to 12 volts to charge the lead acid batteries. So of course, this is a totally pointless circuit, but it just shows how energy can be manipulated by these new types of circuits that you're finding in vehicles. Again, a little snapshot of the different types of circuits here. So we're looking at battery charging, building bigger batteries from smaller ones, looking at corrosion and the faults in battery circuits, pulse width modulation control of motors using a transistor, generating three-phase. There's a half wave rectifier for three-phase there, and then that charging system faults, which I just showed you. Okay, the last product in this release is an oscilloscope trainer. Throughout the packages you've seen, in the first two, there's no oscilloscope use. That's just a multimeter and a clamp meter. But in the second batch, we start to introduce the use of oscilloscopes. You don't have to have an oscilloscope to go through these packs. It will mean you miss out a few of the experiments, but increasingly it does require the use of oscilloscope. And the problem with oscilloscopes is they're not easy to use. If you're an electronic engineer, you've probably spent a long time using oscilloscopes, and even then they're not that simple. So what we've done is we've just made this little electronic gadget that contains a lot of different oscilloscope signals that you find in a vehicle so that students can practice triggering the oscilloscope. There's a couple of basic waveforms, a sine and a triangle waveform, and then there's about 13 or 14 different signals that you find in real vehicles. So we've got a camshaft, a crankshaft, I think that's a crankshaft, that's a MAF sensor, I think, and we've got various other signals that you'll find. And we did this using my car, which is a VW Passat, and we just got hold of a number of signals that we could find. And it is our anticipation that we have not actually included the waveforms that people really want. But what we have here at Matrix is some software where we can take signals that are captured with a picoscope, and we can then add those to the list of oscillograms that's included. And so we anticipate that over time, this list will change. And we even anticipate that manufacturers will request that we build this device with just their signals in. And you can either have known good signals, or you could include a mixture of good and bad signals so that students can start to practice diagnostics of signals using traces captured from a real vehicle. So that's a very strange product. It's not an electronics product. We're very good at this kind of electronics development, and we think that that's a valid inclusion in the range. Again, this is the only pack that's not quite finished. We're just tickling the worksheet a little bit, but I anticipate that within a week or two, we'll have that workbook for you to download. Okay, so this is the 6 kits, 2 at level 2, 2 at level 1 and 2, and 4 at level 2 and 3. It's our biggest ever product launch, I think, 6 products at once, and they're all available now. So you can go out and start selling them immediately. Okay, I think that's all I've got to say.
Good. All right. Thanks, John. Just going to turn the camera around. Stop the share. Okay. I know that there were a few questions that came into the chat. Alistair, did we manage to answer any of the questions that came in?
Yeah, I think there might have been one private to you, but the others I've answered.
The multimeter stuff. Okay, yeah. I think we've answered that with regards to multimeters. There is a question in the chat. Okay, good.
I am a Tesla guy. I just can't afford it. 80 grand on there, something.
Does anyone have any questions? You are all on mute at the moment, but you can unmute yourself and ask any questions. But if you've got any questions that you want to put in the chat, then you can do that as well. Once we've answered a few questions, John has a little demonstration that we've set up that we'd just like to show you as well.
Yeah, so the multimeters and clamp meters are not included, but we do have prices for them. And as Jeff says, sometimes people want a one-stop shop, so we can include those if people want them.
Yeah, that's something that I think with the few quotes that we've already done for this range, we've included meters and things. But of course, they can be sourced locally if it's easier for you, whichever works. Hi, Scott.
Hey. Hello, quick question. So is there a list of all of the faults that the teacher could review and kind of just get the scope of all the different faults that are built into the system?
That's a good question. And no, Scott, there isn't. That's an interesting one because partly the answer is, look, if you take that lighting circuit, well, you put as many faults in it as you like. And now you have those faulty components, you can put them in wherever you like. And actually, one of the things about electronics is you've always been able to do this. You've always been able to put an extra short circuit in if you like, or you've been able to put a faulty resistor in or anything like that. I think if you can build the circuit, you can put lots of faults in. But I really like the question because you're right. It is actually something that customers might want to know. So I'll have a think about that and see if I can come up with a list.
Yeah, and I think sometimes until you prescribe it for people and actually write it down, they won't necessarily think about it. So we'll have a think about how we can do that. And of course, by showing them the curriculum for fault finding there, they'll get a good flavour for what's possible.
Thanks, guys.
All right. Good. All right. Do we want to have a look at that circuit that's set up? If anyone's got any questions, you can be having a think, pop them in the chat, or we can take questions again in another few minutes. So I'm just going to switch over the and Megatech. Thanks for the feedback. It's good that you like the direction that we're taking. Right. I'm just going to switch the camera first, and I'll also switch the mic. So just give me a moment.
Our agents, our friends will like that because you've just inserted a new fault. And it had me flummoxed for a few minutes there, but I'm on top of it now, okay?
Right, John, over to you then. Quick demonstration.
Okay, so what I've got here is this is the ECU that we talked about. So you can see the micro ECU in the center. It's got a little display. I don't know if that's coming out on the camera. A couple of switches to choose the program. This is 12 volts coming from a standard power supply. You've got a couple of circuit breakers there. There's a relay output. I'm not using that. I'm just using this transistor to drive this little motor. So I'm going to select program 10.
You won't be able to see them.
So I'm selecting program 10. Now there's a thermistor here. It's a little standard thermistor. The other half of the potential divider is the input circuitry here. And it's telling me that the temperature at the moment is 22 degrees. And this is a little program where you can set the point at which the fan heater will come on. So if I just, if I hold this, what am I doing? I've forgotten what I'm doing already. The temperature is rising, but if I set now the temperature to be, say, 24 degrees, so as I heat the thermistor, the motor goes off. And if I release it, as the thermistor cools down, the fan heater will come on again. There you go. So that's just a quick view of how that works. Of course, you can put that really big motor. Here's the motor generator pair. Does that come on the camera, Liam?
Move it up a little bit, just move, yeah.
Okay, let's just move that. Oops. So you can see here's this motor generator pair. It's on a big block of steel. It really is chunky. It's very, very rugged. Nobody's going to break that. And if you want, of course, you can put that on this circuit. The only thing you'll have to do is provide a slightly beefier power supply, because our standard plug-top power supplies won't provide what that needs. But you can see there the 4mm connectors for the motor driver. The output's just connected there when it's in use. And you can see how small that motor is. They really are lovely devices, those brushless DC motors. Okay.
With the DC motor, brushless DC motor pair there that's on the screen, just to explain, the idea is that for all but two of the kits at level 1 and 2, the automotive basic kit and the fault finding kit, this is needed for all but those two. Technically, it is best if people have one of these per student and then a kit for the for each of the students to work on almost. But of course, everything's always dictated by budget, and we can work with you. We did another one of these presentations earlier today, and what I said to our partners and dealers that were on the presentation earlier is that with your first quotes, if you want me to have a look over them, or John or Alistair to look over them, just to make sure that what you're offering is right in terms of numbers, etc., then we'd be more than happy to do that. Switch back briefly. One of the questions that just came in then was regarding this presentation. This is recording, so I'm going to send you this. Technically, this can be used for customers if you wish, but at the same time, I understand that you might want something shorter because this has probably gone on for 40 minutes or so. Now on our YouTube, there is now a short video, 5-minute video, just introducing this new range. You'll also find all of the curriculum on our website, product introductions to each of these kits as well. So if you want to share those with customers, that's also fine. But I will make sure that we share everything that we've got with you, hopefully by the end of today. Pricing wise, prices vary. The lowest cost kit is the basic automotive electricity kit, and they go up to the high voltage batteries kit, which is the most expensive kit. We will, when we circulate the information, make sure that we circulate again the prices, but I know we already circulated them a couple of weeks ago when we sent you the introductory email for this new range, but I will make sure you get them again. Okay, now we've done the demonstration. Does anyone have any more questions? Again, feel free for speak out, unmute yourself, or drop it into the chat. Either way is absolutely fine. Or feedback.
Some questions. What does Megatech feel about the use of oscilloscopes in automotive and estates?
Yeah, good idea. Megatech, are you able to? Do you guys have any thoughts on use of oscilloscopes out there in the US? There's a question that's just come in the chat about the availability of the kits, and I can confirm they are available now. Yes. Okay.
Nobody from Megatech there.
I think they are, but maybe they just don't have.
Are they shy? You know, I haven't met anybody from Megatech who's shy. They are used.
Yes, they are used in the US. That's good then.
That can't be Phil then. Is Phil there?
It's probably Haley, I anticipate.
Is he? Okay.
Okay. The mic's not working, that's why.
Uh,
But they've said it's not so much used in the high schools.
No, yeah, I get that.
But in high schools, though, in the US, they do automotive
Do
teaching.
they? Right. Okay.
Which is interesting because, of course, here in the UK, it's not something
No,
that's
we don't.
done until the sort of equivalent of a community college. So, you know, even any automotive teaching in high schools is not familiar to us in the UK. But yeah, I understand in the US it is done. Okay. If anyone, I'll give it another minute. If you don't have questions, I suppose that's a good sign. Hopefully we've answered all your questions. And just to reiterate, these are available now. So we'll get you the prices sent out again today, along with the recording and the presentation. Everything you've got, then to go out and start showing these to customers. We love to interact with customers over this type of webinar as well. So if you have any opportunities where your customers might want to see some of the kits working or chat to us about what we've done here, we'll support you on those. Don't hesitate to just drop us a line and we'll set something up. Okay. All right. I think that should cover it then. If you have any questions afterwards that come to you, don't hesitate to get in touch with myself, John, or Alistair. Be more than happy to hear from you. And thanks for joining us. We'll be in touch soon. Cheers, guys. Goodbye. Have a good day.
Have a great day, guys. Thank you.